ago, and I realized that I'm hopefully sharing the right screen. You can see the Enterprise Tech Leadership Summit. Yeah.
Yes, we can.
Okay. So I'm going to start with this before my presentation because I wanted to explain something about my presentation. It was developed for this conference, for the 2024 version of this conference, this Enterprise Tech Leadership Summit. It was presented there last year. When this JAMSIM conference came about, I did not have time to both develop and get clearance to present a different presentation. So I'm reusing that presentation. But I should tell you, at that presentation and the one you're going to see today, I didn't tell people it was about simulation. You all know this is about simulation, so that's fine. But you're going to find some of the slides a little odd because it hides the fact that there's a simulation involved to begin with. So please keep that in mind as you're looking at the slides. But also, this conference kind of assumed that people were familiar with Agile software development or just Agile development in general. I can't necessarily assume that for this conference. I'm expecting a lot of you will be familiar with Scrum and Agile and so on, but this is a useful diagram anyway. This is from scrum.org. It's included in the Scrum guide, and it shows how most modern software development happens, or the majority happens. In the teams are given a backlog of work. This backlog on the left, this product backlog, and what's in this backlog tends to be work of the granularity, something that would add a new feature, say, to a piece of software, something that might take weeks or even a couple of months to do rather than something that could be done in days. So generally, these are called features in this backlog. When the team does some planning, they break that work down into smaller pieces for the 2-week iterations or sprints. Those pieces of work are typically called stories. So the stories sit in the sprint backlog. A team plans for the next couple of weeks to do a number of stories. Then they actually do that work, and they deliver the results of that work. And once they've got enough stories done, then that would match up with finishing a feature that originated from the product backlog. So you can probably see from here that this seems like a very straightforward thing to simulate, to put those stories as objects and the features as containers for the objects and pass them through a processor called the team and get the results out to see how fast things are going. I'll get back to that in a second, but I want to also mention that Scrum was developed for small teams, a handful of people, maybe a handful to a dozen people for a single team. Since then, the Scaled Agile Framework is one of the most popular ways to scale Agile development. So in this case, you have multiple teams taking from a single backlog, taking features from a single backlog, but then there are multiple teams taken from that. So the solution has to scale at places like Lockheed, obviously. But going back here, you'll notice that in the center, there's people, and people have people problems. And I think, if I recall the other presentations, I don't think there's been another presentation about simulating just what people are doing rather than machines or what's going on with vehicles and transporting things through mines and so on. So these people problems are really at the heart of what causes variance in the productivity of the team, because they're going to face issues that was mentioned in the bio, the features like things like having to do rework. They make mistakes, so they have to do some things again. They get asked to do work that wasn't in their plan, but it's high priority, so it suddenly comes in, has to be dealt with at a high priority. Or they have to attend various events from the corporation, various meetings that are nothing to do directly with their work, but are essential for them. So given that situation, I'll get into the presentation itself. If we can, at a major corporation like Lockheed, where we've got, I think, tens of thousands of engineers, if we can make even a 5 to 10% difference in the performance of teams, then that's a significant financial benefit. So there's a reason for looking at these things and seeing what we can do about it. And as coaches, or even as Scrum Masters, there's a whole toolbox of advice that you can easily find across much of the literature, just articles on the internet, some more technical books like Donald Reinertson's Principles of Product Development Flow. All of these things offer you good advice. They say, well, systems work well because of faster feedback. So if you automate things, things will happen faster, you'll get results faster, you'll spot your mistakes faster, get your rework done faster. That's good advice. That's really good. Keep things small. Small batch sizes go through workflows faster because they hit fewer impediments because they're only a small unit. You have some more things to manage then, but you also can more quickly get through small pieces of work and get feedback from those as well, and so on. This is only a sampling of the advice. But the problem is, which is the most cost-effective to use? It was really starting to frustrate me that we would say, well, we're taking an economic view. That's Scaled Agile Principles number 1 is take an economic view. Remember, this was presented in Vegas, so we're talking about investments at the gambling table here. But we take an economic view, then... But what we're doing is using our intuition to say, if we invest in a change, which costs something, it's disruptive at times, a change, change is not free. So if we're going to invest in a change, we need to know what kind of return we're going to get on that investment. So we shouldn't really be using our intuition. It was frustrating me more and more that we were trying to use just our intuition to properly make important decisions. So I thought, well, we could use a simulation. If you ask me later, there's a story actually about going to Vegas and learning about JamSim the same day. But what we've got here is what was when I presented this at the conference. I said that this was data about some teams from Lockheed. That wasn't true. This was really a specification, a kind of specification for the behavior of the simulation, that the teams were planned within capacity. They based the capacity on their average velocity from previous runs of the simulation. They'd work through the stories in priority order and only one story per person at a time. So there weren't multiple people working on the same story, or one story wasn't worked on by multiple people. They would use the Scrum. It would model the Scrum sequence of events. The team sizes would just be 5 engineers or testers. There'd be relative estimation. I won't go into story points, but there are relative estimation size rather than using hours directly. Story points are a rough estimate of how much time something's going to take, how much effort it's going to take. And for one story point, we chose that we said that would take about a day. And then that was part of the definition. There's some more here that when more than one person has no work to pull from the sprint backlog, they would pull more work from the team backlog. So they may have planned to do so much work, but now they're not. That work has been done, and they're not busy, so they can take some more work. So they're not limited to what they planned. If they don't finish, if the team doesn't finish all the work that was in progress when the sprint ends, that work will continue in the next sprint, and they won't get credit for completing all the work until they finish all of that that piece of work. There's 2-week sprints, which is common, 10 8-hour working days because it's a 2-week sprint. And then we're going to look at what the outcomes were from these teams. So this team in the first sprint, they planned to do 35 points of work. They finished 20 points. I'm not going to go through these what would you suggest for them, because you know they're not real, they're simulations. But note here, there's long periods where no results were delivered. There was no work finished in this period. But in the next sprint, they finished a lot of the work that was started in the prior sprint, so a lot got finished. And although again they planned below 40 points, they actually finished over 50 points. Then in the next sprint, again, they quickly got up to around 38 points, which is about what they planned, but then nothing else happened. Nothing else was finished. But then they finished that in the fourth sprint, and they actually finished nearly 70 points. The fifth sprint was less productive, but let's not worry about that. So what's happening here? Well, we were looking at that sprint by sprint every 2 weeks, but what if we looked at the whole 10 weeks? What if we looked at these different teams? What were the different outcomes? Well, a couple of teams coincidentally had the same number of points, a different pattern of gaining those points, but they actually finished the 10 weeks with 228 points. But some other teams had noticeably less, like 211 points and even 202. And I think, if I remember correctly, there were examples of teams scoring 180, 190 points. So there's a pretty significant difference there, given that these are automated people working full time. And they were perfect in this sense. They were taking 15 minutes to plan the work per story. They followed almost all the given guidelines. They never generated any rework. Their estimations were exactly accurate. They took no time to context switch. They weren't interrupted by the corporation or email or anything. They suffered no interruptions. They took the work exactly in priority order. So that's because they were a simulation, basically. The reason they were not following all the given guidelines is they weren't doing Scrum events. They weren't having meetings. They were simply working through the work. So you know this, it was a simulation. And they were identical teams. They were running through the same simulation. So there's only one piece of randomness in the model that caused those different outcomes for teams, both at the sprint level and for the overall level. So I'm going to ask here if you have an idea where that was. Where was and I can't see the chat. Where's my chat window? I'm afraid I can't see the chat. There we go. Does anyone know where the randomness was in that model? Any ideas? For such different outcomes. Time between points completed. There was no time. There was no time between the points completed. Once someone finished something, if there was work on the team backlog, on the sprint backlog, they would take it right away. And if there was work on they would take 15 minutes to plan it, and then they would start work. The inputs, the backlog, yeah, you're getting really close there about the queue. It was simply the order in which the various sizes of work came in, because there was a 20% chance for each of these different size stories. So an 8-point story is going to take most of a sprint. It's going to be essentially 8 days, whereas a 1-point story is going to be 1 day. So the only difference was the order in which the backlog of stories had different sizes. which was quite a surprise to me. And I should say that I do not have a background in simulation, so I may have messed this up completely. But it seemed to give sensible results. I've got a background in software engineering, so I knew something about what I was doing, but I do not have a background in simulation or in discrete event simulation. But it seemed to me that if I created a set of stories with different sizes, and I gave them to the teams, and I'll show you the steps here. There was a 15-minute planning for each story, and then it would go on to this sprint backlog. The work would be done for the relevant amount of time for the number of points that were estimated for that story. If the sprint finished, well, if that work finished, it would go down here and say, is the sprint still open? Yes, we'll count the points. But if it was interrupted because it was the end of the sprint, it would go through and calculate how much work had been done on the story before it was placed back on the backlog, so that it would be done. Work would be done in the next sprint. So that's how the basic sprint happened. It did get made a little more complicated. I'll show you in a little bit how it was made a little bit more complicated. But the first thing we could learn from this was, if you're a coach or a scrum master and you said, oh, I made some change and I made our team 10% better, that may have been just randomness. There may have been no effect from your change. That you, if you had the perfect team, they could show a 10% improvement just or even more, just through randomness. But there is the benefit here of, well, we could see rather than, someone in a typical career is only going to work on so many projects and they're only going to work through so many sprints. But using a simulation, you can run through literally thousands of these in minutes. So I wanted to use this perfect team as a baseline for adding some extra behavior from the team, those kind of interruptions, these kind of things. First of all, is a story a blocker? Is it going to cause a delay and some extra work when you restart the work to get through a blocker piece of work? Or is there going to be some extra work that's going to be added to the sprint, to the team's backlog that was not planned during the sprint? I put this extra work in red, and I've got a short video here to Lockheed said I couldn't actually show the full model and all the details and everything, but I could show snapshots and things like that. So you can see here, this is a later version of the model that did have the feature containers. So the features and the containers were built up here and then collected together later on after the teams had done their work through each of the sprints. So we got 5 teams and 5 sprints. So this is not the whole run, but you can see here the video is going to zoom in. On the right, you can see the progress of finishing features. What they plan to do as a whole train of teams, and what they actually got complete over time. And then this video is also going to zoom in to show some behavior with those delays and the extra pieces of work. If it will continue a little faster to zoom in. There we go. I wish I could zoom in even further, but you can see there's an extra loop here with that the delay loop, which was for the blockers, and then the red dots that start to appear. There's the delay loop happening, and also the red dots are the extra work that wasn't planned. So that's already having a significant impact on the rate at which teams can actually finish their work. So I was able to add that and some other scenarios as well. For each of these, I had a switch on the model to say, are we going to include blockers, rework, large features? So these were 50% bigger than average. So that was the large batch sizes, unplanned work, interruptions, and context switching. So these are in order of what the impact seemed to be versus the performance of the foundational model, the perfect team. So if you add blockers to a perfect team, you're likely to see, and these are with numbers that I feel are just typical from my experience. These are not based on measured numbers from specific teams. That's something that we would like to do in the future, is to calibrate this model to specific teams and then try and make predictions and see how they turn out, applied to different sets of teams. But if you avoid blockers, if you have blockers, then you're likely to see a 20% reduction in velocity. And that same is approximately the same for rework. If you don't make an effort to keep your quality high and you end up with lots of rework, then you're going to see a similar reduction. Large features, they don't impact how much work you do, but you end up not finishing the features you planned because the ones you have are much bigger, and then the chances of the right stories finishing to complete your feature is much less. Again, with unplanned work, you'll do as much work, but it won't give you the planned features because a lot of the work, by definition, was unplanned. If you have interruptions, they're not as bad as any of the things above. And it's not really because of the context switching, which I think is the reason a lot of people explain why you should avoid interruptions. It's actually the lost hours of work. So if you have your engineers going to, a couple of hours of meetings every day or every other day, then that adds up over time, over the 2 weeks and over the 10 weeks, and they simply have less hours available to do their work. And then context switching seemed to have the least impact, which isn't surprising if you look at it by itself, because if people are only working on, let's say, 3 or 4 stories during the sprint, they are only going to context switch a few times if they're focused on one story at a time. But if you start adding some of these other things in, like interruptions, unplanned work, and so on, the context switching more often. So it is going to be a multiplier across there. So this started to satisfy my interest in, well, can we prioritize what you should work on with a team to give them economically a good return on investment on your advice and the investment they put into change. So just as a conclusion for now, and I'm happy to answer questions as well, remember that if you have a perfect team, just the order of the work might make a 10% impact on their outcomes. Just simply the size of the work that comes in at particular times. But we do see that a simulation like this starts to offer the opportunity for training. This is where we could take people who, especially people in the roles like Scrum Masters, who want to help teams perform better. They can show the teams, they can learn themselves from changing these parameters and seeing what the impact is. And then for more experienced people or coaches, for example, they could actually do what I just talked about, which was actually putting real numbers into the model that are taken from real teams, and then suggest more accurately which changes they might benefit from most. And that's it. That's what I've got for you. But thanks for listening, and thanks also for everyone who's contributed to the conference. It's been really useful for me to hear all these different points of view and technical details about things.
Wow, that's a absolutely fascinating application of a simulation, Anthony. That was really neat. So
Thanks.
There's some questions here coming through the chat, so I can read them out here.
I can see
Yeah,
them
go
as well.
ahead. Okay.
Yeah.
So maybe just maybe
I
talk about
will.
the question for you. Answer
So
it. Yeah.
Justin asks, how do you model a case where a feature is difficult or impossible to subdivide into stories? I don't model that. Remember, there was advice yesterday from Avril Law about picking um, picking what you model. I think you could model this. You could have some cases where you just have very large stories. You say, well, this seems impossible to divide, which is an argument that a lot of people use, but often isn't really true. That you could just allow occasionally very big stories, so you could model that. So Harry says, please explain why the productivity of identical perfect teams varied. Let's see. Let's see if there's a let me go back to the diagram. Oops. Okay. So when the work comes in, it could be I'll use points, but you can substitute day for the word points. So let's say a 3-point story, a 3-day story comes in, and it's the first one on the backlog, and the first person takes that, and they work on it for 3 days. Well, now there's only 7 days left in the sprint. So they'll finish the 3-point story and claim 3 points. The next story that came in that they happened to be the one who picked up, say that's 8 points. So now they need 8 days to finish that. They're not going to finish that by the end of the sprint. They are going to get credit for that when they finish the 8th day during the next sprint. So according to the way Agile measures, I'll say measures outcomes, not so much productivity, but the way they say, what's a team's velocity? A team's velocity is how many points it finished during a period. So now that team member only contributed 3 points. Well, if you end up with that combination happening for everyone on the team, they started with 3-point stories and then followed by 8-point stories. You're going to have 5 times 3 is 15 points for that sprint, which is very unlikely, that combination. But then in the next sprint, it's going to be much higher. So the average velocity is going to stay pretty much the same. It is the same for all the teams. When I ran that 1,000 times, I got, a very, I was able to average that out over lots and lots of combinations. So they have an average velocity that doesn't change their productivity in a sense, but the actual outcomes when it's looked at from the Agile perspective makes it look like they're producing less or producing more. The real impact on productivity is when you add those other interruptions and rework and things like that.
Right. Okay. Thank you. I just wanted to just talk about this verbally here. That was a good explanation. Yeah. So in many, as you're saying, this is really more of a productivity measurement problem than a productivity problem.
Yeah, the actual, just that variance in outcomes for the perfect team, yes. Yeah, but then when you add in various corporate interruptions and the effective blockers when things are not available when they need to be, that's where you start to see productivity is impacted because they're taking more time to complete the same work.
Right, and there's also, and when it carries over to the next sprint, there's some inefficiencies associated with that because of various things. There's some context switching involved.
There is context switching, yeah.
Scope for interruptions, and that's where you start to lose real productivity, not just merely
yes,
just measure. Yeah.
Yeah, I know in half an hour it's hard to explain the subtleties of how some of these things are, especially because it involves people. we're not treating them as machines, but we're trying to measure the teams in some way so that we can make predictions for our stakeholders. When is this going to be ready? I mean, I'm sure you get asked, well, when is the next release of JamSim? And you can have your own estimate, but does it always go to plan?
Yeah. Well, this is familiar from trying to estimate projects when you're writing a fixed price proposal for something, and you've got a team of people working on it, and you're trying to identify all the myriad tasks you're going to have to perform to execute this, and how much contingency do you allow, and all that. It was always challenging.
I think developing simulation models, I've got a very formal background in software development, in specification and so on. So I see a lot of similarities between simulation model developing and software development, a formal approach to software development.
Very good. That was really interesting. Thanks. You.
And I think they're the only questions I see.
I had a quick question, but I know we're 3 minutes behind. My question was, I see the terms agile and sprint mainly apply to software development. And I guess, and my knowledge of this domain is relatively limited. I guess with software development, you have all of these individuals working on what will become either one or two versions of a software program, or in deployment versus development. Are there ways to apply this in more of like manufacturing, or where you're dealing with the physical as opposed to the digital? Like if you're building houses or building cars, where there's you can finish one car or two cars or three cars, and just by the nature of it, maybe there's a defect in one car, and the other cars are completed correctly. I didn't know. Hopefully my question makes sense.
Yes, the application of Agile isn't limited to, or even Scaled Agile is not limited to software development. It's been used in banks or HR or in hardware development. Tends not to be as much in manufacturing itself, because they've got their own like lean manufacturing principles and tools associated with that. So it's not so much the manufacturing itself, but more in the development of the new hardware. And so Lockheed's obviously involved in that as well, because I'm in Lockheed space, so we send things up into space. We make things that go flying in space. So we have an interest in applying this to planning and execution of hardware development projects as well.
Just on that, and I don't know if this is right or not, but I know that at least when Tesla was first that first sort of set of Model 3s that they came out with, like maybe 5 or 8 years ago, that they were letting them kind of go into the hands of consumers, knowing that there were bugs, because their preference was to get them out and get experience and then solve it later.
Well, Microsoft did with Windows. And I happen to have a Tesla Model 3 from 2019. And I've got the full self-driving software. So yes, the Tesla's actually taken a more agile approach into manufacturing, because they have tests on the production line. They have tests at each step to say, is this piece of production work good or is it failing? Which means that if they say, oh well, maybe if we change the design of the heat pump in some way, or whatever component, and we'll try that out on the production line, and if it passes the test, we can ship it. It's going to have a slight variant from the one that just went before, that went to a customer, but this one is going to be better because we've incorporated the better design and it passes the test, so it's good. Or it fails the test, and then they take it back and rework it. So they've taken it somewhat to the extreme, as well as SpaceX. The same guys behind that as well, and SpaceX have done the same, because you'll see them regularly flying and crashing and learning their lessons. Lockheed doesn't seem to have that. Whether it's a mindset or whether it's the political situation, well, if Lockheed crashed something, then that's a congressional investigation, versus if SpaceX crash it, then maybe that was just an experiment and they went wrong. But we'll learn lessons. So that they're all following agile principles, doing that, the crashing and burning. So the principles themselves can be, applied to in many different ways.
It's really fascinating.